Good morning, students. So here with 2C numericals. The first question is: a ball of mass 0.20 kg is thrown vertically upwards with initial velocity of 20 meter per second. Calculate the maximum potential energy it gains as it goes up. So, bacha, the maximum potential energy will be equal to the maximum kinetic energy when you are throwing a ball, because energy throughout the procedure will remain constant. So here potential energy at maximum height will be equal to half mv square, which is equal to the maximum kinetic energy. So we get the value as 40 joules. The second question we are having here: a mass is given to us. A stone of mass 500 gram is thrown vertically upwards with a velocity of 15 meter per second. You have to calculate the potential energy at the greatest height. Again, the potential energy at the greatest height will be equal to the kinetic energy. Fine, this is we have done in freely falling. Maximum height, here the maximum kinetic energy where it appears to touch the ground, and here we are having the sum of potential and kinetic energy. But in all the three cases, energy will remain same. So in the first case, mgh will be equal to half mv square, so the value is 56.25. In the second case, it's again kinetic energy they are asking, so that is half mv square. The total energy at its halfway as potential energy plus kinetic energy will remain constant throughout the procedure, so it is also equal to 56.25 joules. Okay, third question we are having here: metal ball of mass 2 kg is allowed to fall freely from rest from a height of 5 meter above the ground. So you have to calculate the potential energy possessed and the kinetic energy. Again, bacha, the kinetic energy of ball just hit in the ground is equal to the initial potential energy, that is the maximum potential energy, which is equal to mgh. So here kinetic energy is equal to mgh. Okay, so that is the potential energy possessed by the body when it's initially as rest, that is also mgh. The kinetic energy, that is also equal to mgh. What happens to the mechanical energy after the ball hits the ground and comes to rest? So when it hits the ground, the mechanical energy is actually converting into the sound energy. The losses energy in the form of heat, friction, so that's conversion will be there. Okay, now the fourth numerical. Here in the fourth numerical we are having a diagram is given, but it is given in your book that, see, a diagram is here in your book. A diagram given below show a sky jump. A skier weighing 60 kgf stand at point A at the top of the sky jump, and he comes to take off from he moves from A and takes off for his jump at B. Okay, so you have to calculate the change in the gravitational potential energy. So the lossful energy will be mg h1 minus h2. So that is equal to mg h1 minus h2. Putting down the values, you will get the result. The second point they are saying, if 75% of the energy part A becomes kinetic energy, so you will find out 75% of this. 75% of this will give you what? The value of the kinetic energy at B. Calculate the speed. So basically they have given you the value of the energy at the point B. You are having the value of the energy at the point B. We have calculated the 75% of this energy, and you have also know the value of M. So by putting the values, we can find out the value of V. So its V square is coming out to be this. So when you take its under the root, that is V square is equal to 900. V is equal to under the root of 900. This 9 will give you 3, and because of these two zeros, 0 will be there. So here is 30 meter per second. Okay. Now the fifth question: a hydroelectric power station takes its water from a lake whose water level is at a height of 50 meter above the turbine. Assuming an overall efficiency is 40%, calculate the mass of the water which must flow through the turbine each second to produce a power output of 1 megawatt. See, potential energy is given to you, efficiency is given to you, so useful work done will be 40% of that potential energy. So you will get the value of potential energy. And what is power? Power is work done upon time. Here they are asking you, here they have time is given to you, that is 1 second. So this is work done upon time, where t is equal to 1 second. So power is actually equal to what? The work done. Power is given to you 1 megawatt, and here are work done. M value we don't know. that is 200 m. So I directly write here 200 m, which is the mass of the water flowing through each second. So megawatt is 10 raised to power 6 watt is equal to 200. Putting down the values, you will get the mass as 5000 kg. The last question of your syllabus. So here we are having a bob of a simple pendulum is imparted a velocity of 5 meter per second. Velocity is given to you when it is at its mean position. To what maximum vertical height will it reach? Will it rise on reaching at its extreme position if 60% of its energy is lost in overcoming the friction of air? So energy lost will be 60%, so energy available to them, that is only 40%. Okay, so what we are having, half mv square into 40 upon 100, that will be equal to the value of mgh. G value is given to you, that is 10. See beta, 60% is lost, so how much energy is left with you? 40%. So energy available is 40% of the total kinetic energy. Okay, so that is 40% of the total kinetic energy, and we know that when they are converting, the kinetic energy will be equal to the potential energy, because at one point potential energy plus kinetic energy, or kinetic energy plus potential energy, when we are having, like in one case potential energy is 0 and in another case kinetic energy is 0. So according to the energy conservation, as it's converting from one energy form to another energy form, so here what we are having, that is this half mv square into the 40% of it is equal to mgh. Putting down all the values, you will get the value of h as 0.5 meter. Thank you very much. Still you are having doubts, you are always welcome.